Hello guys and welcome to another A plus 220 1201 lesson. This time we're going to be having a look at exam objective 4.1. You're done with exam objective 3. Congratulations. 4.1, we're going to be taking a look at virtualization concepts, all right? So some virtual machine stuff coming up. Let's go ahead, get straight into it. I'm going to tell you what you need to know, the kind of questions you might be asked, and give you some practice questions so you can see if you're actually ready for the exam. Let's go ahead and get to it, starting with the purpose of virtual machines. Let's go. So, what is a virtual machine? Basically, it is software on a computer that mimics a physical machine. So, for example, you might have your computer, but you might install a program on your computer that is a virtual machine. Now, what you can then do is, using your machine, you can actually go in and turn on the virtual machine, and it's almost as though you're using a completely different computer. So some reasons you may want to do this, right? Maybe you have a Windows computer, but you actually want to run some Mac applications. You don't have to go out and buy a Mac. No, you can install a Mac virtual machine on your Windows computer to run those applications, right? Just as an example. So that's briefly speaking what a virtual machine is. And for your exam, you pretty much just need to understand what I said there, and you need to know the different uses for these virtual machines in particular. We're going to get into that right now. So the first one is a sandbox. All right, a sandbox. Now, essentially, a sandbox environment is a secure and isolated digital space where you can experiment, test, or run potentially risky operations without impacting your existing systems or network. So have a look at this picture over on the left, right? This pretty much represents a sandbox pretty well. You may have a grenade, in relation to your network. It wouldn't be a grenade. It might be a file that you've downloaded, but maybe you suspect it is malware. You can safely throw that grenade into the sandbox knowing that you are protected, and if it goes off, it will only impact what is in that sandbox, right? So in this case, that sandbox would be a virtual machine. So basically, you could open that file in a virtual machine. If it is malware, that's all right. You can close down the virtual machine. No problem. You can safely test out potentially dangerous things in a sandbox. So if anything goes wrong, the damage is contained within the sandbox. That's the primary purpose of a sandbox. Containing damage, testing things you think may be dangerous. So purpose, it's used for testing untrusted software, analyzing malware, or trying out new configurations that may potentially blow up in your face, right? That's the key thing. Pause and read the rest, but that's really what you need to know. The next thing is a little bit similar, and I'm going to clarify it in the next section, but it is test development, all right? So test development involves using secure environments to safely trial application code and implement changes without risking harm to your network or devices. So it's a similar concept in that you are testing and you are doing it in a virtual machine in order to make sure that you don't damage anything else. But it's not so much about testing malware or potentially dangerous files. It's more about maybe you've made a change to your code, and instead of applying that change in code to your system right now, maybe you want to open up a virtual machine and try running that code change there so you can see how it might impact that machine. And maybe if it goes wrong and it completely messes up the computer, now you don't have to worry about trying to fix that because it was in a virtual machine, so it's no problem. So you can run any changes to your code in a test development setting. That's a test development is a reason you would use a virtual machine to do that, right? Ensuring no unintended effects on your network or devices, all right? So you can create a copy of your code or your application and then make some changes in the virtual machine. And those are going to be pretty risk-free overall, right? So it's a controlled environment to do that testing that you might want to do. It's not about testing malware files. It's about testing changes to your code, right? That's what test development is about. So the key differences here, to make it really pinpoint clear, a sandbox is generally used for testing in isolation, especially for identifying vulnerabilities or experimenting with risky configurations, specifically like malware, right? So it's designed to contain potential harm and ensure safety during testing. However, test development, it focuses on refining and debugging code or applications, ensuring they're ready for implementation without negatively affecting the main system, right? That's kind of the key distinction between the two. In your question, it should be pretty clear what they're doing. Like, it might sound a little bit difficult here, but when you get a question, it should be clear what the right choice is, so long as you understand that, right? We're going to go ahead and move on to the next reason you might use a virtual machine, which is application virtualization. Now, this is an overarching idea, and you need to know two specific types of this, but basically what it means is you might want to run a virtual machine on your computer, either to use old software or to use software that doesn't run on your native operating system. So it's the example I gave before about running Windows programs on Mac or Mac programs on Windows. Application virtualization allows you to do this. And let's have a look at the two ways you need to know about for your exam that it lets you do that. So the first one is legacy software and operating systems. Some older applications were designed to run on outdated operating systems that are no longer supported on modern machines. With application virtualization, you can do the following, right? Pretty much what's seen over here. Let's say this is your computer. Application virtualization essentially allows you to run some older programs that might not be compatible with your modern OS. So you could actually install a virtual machine running an older operating system, and then you could go into your virtual machine in order to run and use that software or those programs. And that virtual machine would of course be stored in your computer itself. So as far as that virtual machine is concerned, it is that older legacy software. It is that older computer running that older operating system, but you know it's a virtual machine. It's the matrix, right? You know, they don't know. So you can create a virtual machine and install the required older operating system, right? You might want to do something with Windows XP or some older Linux distributions. You can then run your legacy software in that virtualized environment. So that is legacy software and operating systems. You need to just basically get your head around that general principle. The other one is cross-platform virtualization. That's what I was talking about running Windows on a Mac, or about maybe you want to practice your penetration testing, right? Coming up. Maybe you want to be a penetration tester, get into cybersecurity. At some point, you're going to have to install a Kali Linux virtual machine so you can practice using that operating system and the tools that come with it. But you might only have a Windows computer. So cross-platform virtualization essentially allows you to say, hey, I have a Windows, I'm going to install a Kali Linux virtual machine on my computer, and that way I can use all of those cool penetration testing tools that otherwise I wouldn't be able to use. Okay, so it allows you to run programs from other operating systems on your computer by installing a virtual machine and then running that operating system on that virtual machine. So this is all just ways that you can use virtual machines, is essentially what this is, guys. You just need to know and be able to say, okay, based on that situation that they've given me in my exam question, they are using virtual machines to do cross-platform virtualization. Or they are using virtual machines to do legacy software and operating systems. Or they are using virtual machines to do as a sandbox environment, right? That's kind of what you need to know for your exam. So with that being said, we need to have a look at some of the requirements you need to, because not every computer can run a virtual machine. You need some specific requirements. The first one is hardware requirements. Hardware requirements. You do need a specific, something specific in your processor, in your CPU. If you have an Intel CPU, you do need Intel VTX. You're going to need to make sure your CPU has Intel VTX in order to use virtual machines. Or if you have an AMD CPU, you are going to need to make sure you have AMD V with that CPU, otherwise you won't be able to use virtual machines. Of course, you'll need enough RAM and enough storage to be able to run it on your system as well, because the virtual machine does utilize your primary system storage, okay? That is important to understand too. You also need to have something called a hypervisor, which we'll get into a little more, but basically that is like a software that allows you to actually use a virtual machine. It takes responsibility for running that virtual machine, all right? So you are going to be using VMware or Hyper-V or VirtualBox as a hypervisor. Those are all examples of hypervisors coming up in your later certifications that you do if you move into the cybersecurity sphere, like I said, to install virtual machines on your own device. But for now, just know you need a hypervisor to manage those virtual machines, all right? And of course, have enough power, have enough cooling to be able to run the VM. You don't want to overheat, right? So security requirements as well, guys. Basically, with a virtual machine, I know we've talked about sandboxing, but you do want to make sure you still use all of those security configurations that you would use in a regular computer, because it is actually possible for you to have a VM escape, which you really don't need to know about for this exam, but you just need to know that malware or whatever can actually, in rare instances, escape the virtual machine, go onto your main system and enter your network if you're not careful. So you do want to treat it as it is a real life machine. And of course, you want to make sure you're very careful about downloading and installing third-party virtual machines. Make sure you trust where you get your virtual machines from, because they could be containing malicious software, right? And you don't want that to be something that you have happen to you, all right? So you also need network, some network things you have to consider. You have to consider that you need to have a reliable high-speed internet connection, and your network configuration is also something that you have to consider. So you have some different network options. You have something called bridged networking, which is basically where the virtual machine is treated as an independent device on the host network with its own IP address. You might want that if your virtual machine needs direct communication with other network devices. You can also do network address translation, which is basically what we talked about with how routers turn public IPs into private IPs, but your computer's doing that for your virtual machine. So it's basically where your virtual machine can manage their connection to external networks. With network address translation enabled, the virtual machine shares the host computer's IP address. So you've got IP sharing. As far as everyone outside of your computer is concerned, you've got the same IP address. So it provides better security because it hides the VM from direct access. In the same way, when we talked about IP addressing, your router hides your private IP addresses of your device in your house from external access. Your computer's IP address can hide your VM, so no one can access it from outside. They have to go through your computer using your IP address. Host-only networking is basically when the VM can only communicate with the host system, and internal networking really allows communication only among VMs on the same hypervisor. So you really don't need to know all that in detail, guys. You just need to know there's a variety of networking configurations, and you need to have like an idea of using one of those and the fact that they exist. Now, you need to make sure you have enough IP addresses if you're using a network configuration where your virtual machine is going to be using its own IP address. And of course, your firewall and security settings, keep them the same as I talked about in the security section, and make sure you have enough bandwidth, right? You want to be able to handle the network load generated by the virtual machine, okay? So that's pretty much it for that. Storage, you need to make sure you have enough storage, right? Virtual machines come in something called a virtual disk file, or VMDK, VDI, to store the operating system. You need to make sure you have enough storage for all of that, right? That's pretty much it. Make sure you have enough storage for your virtual machine, long story short, okay? When you are setting up your virtual machine, you can have it to a fixed size or dynamically allocated. If it's dynamically allocated, that pretty much means as your virtual machine gets more files and folders, it will actually grow and use more of your native system's resources. If it's a fixed size, it will not grow, all right? It will not grow past what you've set it to. So consider that as well. Okay, desktop virtualization, guys. You can pause and read these notes, but basically what desktop virtualization is, let's say you've got 3 computers here. This one's Pete, this one's Bob, this one's Julie. And they all have to come into work and use their computers. However, their work doesn't want to have physical computers at this location. They don't want to pay for all this hardware, right? What they want to do instead is they want to have a server, maybe on-site, maybe off-site, and they want to have Bob, whatever I called him, Sam and Julie, come in and just use a very lightweight device with not a lot of hardware capabilities. But that device is then going to go ahead and access the actual desktop on the cloud, right? And they're going to use that desktop on the cloud. So the cloud might have like one desktop here, resources for another desktop, resources for another desktop, resources for another desktop. So when these guys come into work, their computer is not actually stored on that device that they're using, which is often going to be a very lightweight device. Instead, they just use that device to access the cloud resources, which actually hosts all the hardware for their desktop. So they're accessing these resources over the network to have the desktop appear on their device here. Hopefully that made sense. Look, long story short, not long story short, I guess a little bit more detail, it's basically a technology that enables users to run desktop environments, including the operating system and applications, independently from the physical hardware, right? Because all the hardware is on the server, but you're running that over the network on your device over here, okay? So you don't have to have that hardware in your device itself. It decouples the desktop from the physical device, allowing the desktop to be hosted on a centralized server or cloud infrastructure and accessed remotely. So it's basically a desktop that you're accessing remotely. Long story short, that's pretty much what it means. Why would you want to do this? Well, it does allow for centralized management, right? The IT administrators can manage, update, and secure all virtual desktops from a single location. Remote access as well, no matter where you work, you can access that server, you can access that from anywhere because it's over the network, and it's very scalable, right? Absolutely. It's also very scalable, and it's enhanced security because the data is stored on centralized servers rather than individual devices. You can't really run away with a whole server. You're not going to break in and steal a whole server, but you can break in and steal a computer itself. So this kind of bypasses that issue, because if someone steals a computer, you can just lock that computer out of the connection, and then whoever stole it gets nothing. So that's something to consider as well. The next thing you need to know about are containers. Basically, guys, look, this is going to be a case where I say you can pause and read these notes. Pause and read these notes if you want. There's a lot of good information in there. It's from my learning guide. I'm just not going to talk all the way through them. For containers, basically what you need to know is, let's say this is your phone, right? Just for example's sake, this is your phone, and on your phone, you have a lot of different apps. Now, those apps are contained within containers. What that means is all of the data that this app really needs, all of the coding and the programming and everything is within that container. The only other thing that container needs is just access to the physical resources of the device, right? In order to run it. But all of the data is within that container. That's pretty much what a container is, guys. It's just containing all of the data required for that particular application or task inside of the container itself. And so long as that container has access to the resources of the device that it is hosted on, it's going to be able to run itself. So it's just a way of organizing your resources, essentially, when it comes to applications or data to that effect. So, guys, again, pause and have a read. You can have a read at more detail what containers are, analogy here, and some benefits, why you might want to do it, right? But just understand that concept that I laid out, and it should be okay. Pause and have a read of that if you want, but I'm going to move on, okay? Hypervisors, I think, is the last thing that we need to know about. It's basically that software that I said we would talk about in a little bit more detail, and it's that software that manages the virtual machines, okay? There are two different types of hypervisors that you need to know about. The first is type 1, and the second is type 2, and I think it's best described or shown in imagery. So let's have a look at these images. Type 1 is called the bare metal hypervisor, and that's basically where you have your hardware, and directly on top of that, you have your hypervisor, and your hypervisor manages your virtual machines, okay? Now, the difference is in type 2, I'm sure you can already see the difference. You've got your hardware, and then you install the operating system on top of your hardware, and then you install the hypervisor, which then manages the virtual machine. So the only difference is type 1, there is no operating system. Type 2, there is an operating system. That's the key difference you need to know about. Now, we're going to get to your practice exam questions. Stay with me, and let's see if you are ready for your exam. The first question reads, Jacob is preparing a testing environment for a new software application. He needs a solution that provides isolation to safely test unknown programs, refine and debug his code without interfering with his existing system, and ensure applications run smoothly across different platforms. Depending on his requirements, he considers different methods, including sandboxing, test development environments, and application virtualization. Which of the following best outlines the differences between sandboxing and test development? A. Sandboxing and test development are identical, both exclusively used for debugging software. B. Sandboxing isolates potential threats while test development focuses on refining and testing code before deployment. C. Test development environments are primarily designed for malware analysis rather than improving applications, which is the primary use case for sandboxing. Or D. Sandboxing does not provide isolation, making it less useful for security testing. Your answer coming up in 3, 2, sorry, had to move around to see where the answer was. 1, pause the video if you need more time, and we're going in. The answer is B. Sandboxing isolates potential threats while test development focuses on refining and testing code before deployment. Guys, we talked about that. Hopefully we got that right. If not, go back and do some more study, I guess. Just read that, know the difference between sandboxing and test development. You'll need to know it for your exam. The next question reads, Liam is working on a new software project that requires testing in a controlled environment. He sets up a system where he can run older applications that are not compatible with his current operating system. So he creates a separate virtual environment to host them. Which of the following best describes the type of environment Liam is using? A. Sandbox. B. Test development. C. Application virtualization. Or D. Cross-platform virtualization. Pause video if you need more time, your answer is coming up in 3, in 2, in 1. Let's go to the answer. It is application virtualization, which was C. So this was talking really about, was it legacy? Let me have a look. What was it saying? Let me get my head around it. He was saying older applications. So really he was talking about legacy systems. So you should have had legacy systems in your mind, but then you would have come down to have a look and seen, oh, there is no legacy systems. Well, it's not sandbox, it's not test development, and it's not cross-platform. Legacy systems is a subcategory of application virtualization, so I guess this is the best answer. Sometimes you have to be able to find the best answer, right? Technically, legacy systems would have been the reason, but it's not there. So this is the next best answer. Okay, the others would have been incorrect. Now, moving on to the next question, which reads, Michael works for a company that provides employees with remote access to their work desktops from any device. Instead of using traditional physical desktops, the company hosts all desktop environments on centralized servers, allowing employees to securely log in from laptops, tablets, or smartphones. IT administrators manage these desktops from a central location, ensuring security updates and software patches are applied efficiently. The system also enables scalable deployment, making it easy to add or remove users based on demand. Which of the following best describes that technology? The technology Michael's company is using. A, test development environment. B, VDI. C, DIV. D, SAN network. Pause the video if you need more time. Your answer's coming in 3, 2, 1. Here we go. It is B, VDI, Virtual Desktop Infrastructure. We talked about what that was, how it works. Have a read if you need more help with that. But long story short, you just need to know. VDI, DIV, I made that up. There's no getting around that. I made that up. All right, guys. Look, the next question reads, Sarah is deploying applications in a cloud environment and wants an efficient way to package and run them without relying on a full virtual machine. She sets up isolated environments that include everything the application needs to function, such as libraries and dependencies, while sharing the host operating system's kernel. This approach allows her to quickly scale workloads, migrate applications across different platforms, and enhance security when running multiple processes in parallel. Which of the following best describes the technology Sarah is using? A, Virtual Desktop Infrastructure, or VDI. B, Test Development Environment. Or C, Containers. Or D, Application Virtualization. Pause the video if you need more time. Your answer coming in 3, 2, 1. Here we go. It is C, containers, guys. That is very absolutely describing containers, all right? So pause the video, read that if you need more information. We did go over that, all right? So this is just to test your knowledge. Now, guys, looks like I have another one for you. I'm really giving you a lot of questions here. Holy smokes. I regret this. Okay, let's make this the last one. This question reads, James is setting up multiple virtual machines on a single physical server. To efficiently manage these virtual machines, he uses specialized software that allows them to run independently while sharing system resources. This software ensures that each virtual machine remains isolated, optimizes performance, and controls hardware allocation across virtual environments. What software is James using? A, AMDV. B, EXT Tech. C, Hypervisor. D, Digitizer. Pause the video if you need more time. We're going to get to it in 3, 2, 1. Here we go. It is C, Hypervisor, guys. The Hypervisor, it's a bit small there, sorry. Hypervisor is what's responsible for running those VMs and managing them, okay? We do need to know that, all right? So, with that being said, please make that the last one for the sake of my voice. Yes, if you enjoy my content, you can, and you want to test to see if you're ready for the actual exam, you can head over to the link in the description or the pinned comment to get a free practice exam. You'll literally just be able to click that download button, no strings attached, download it. In that, you've got 3 performance-based questions, you've got 90 multiple choice questions, and then if you like that, or if you want to jump straight to this, you can also get my learning guide. Helped me pass my test today, says this guy. So if I helped him pass, I can help you pass as well. In my learning guide, you pretty much get the following, guys. First of all, some more good words from others. Your learning guide is actually goated. I don't comment a lot, but it definitely helps with organized information and helps me piece things together more easily. Thank you so much. Glad I could help. I downloaded your learning guide already, and I can see it will help immensely with studying. I tried other popular resources, but struggled absorbing the material. Will you have one for the A+ 1102? I do, absolutely. So guys, in my learning guide, you get everything broken down by exam objective and into the actual individual dot points as well. So for all of that, you get notes, you get multiple choice questions, you get detailed answers, just like everything you've seen here. You get 11 performance-based questions in there as well. And you also get a troubleshooting simulation where you can actually click through to these buttons and get this troubleshooting simulation. You can click on all the buttons, help the people out with the issues, get a really well-rounded idea of clicking buttons and working your way through the PBQs there. And you also get a video where I tell you how to use AI to learn things like 10 times faster, and you get a video where I tell you how to use multiple choice questions to study efficiently. Most people think they know how to do it, but they really don't, guys. They do it inefficiently. I'll tell you how to do it the right way. So with that being said, that's all over at journeytosaba.com/1201, or you can click the link in the description or the pinned comment. I'm going to go eat some lunch because my throat's killing me and I am hungry. See you guys in the next one. Can't wait for you to tell me that you passed your exam. Bye.